All right, we'll get started. First off, thank you for being here at the Tigergraph webinar to learn about Giraffle. Giraffle is an open source tool. You'll learn all about it today. It is being used to manage deployments at an enterprise scale, and we'll introduce myself. My name is John Herkey. I'm a technology evangelist here at Tigergraph. I have a 6-year background at United Health Group as a senior software engineer and also as an entrepreneur in residence. I'm a founder of Futures Academy, which is a nonprofit that is looking at taking emerging technologies and bringing them into the school systems. I have 8 years of military experience deploying remote networks, and also have a Bachelor in Science Computer Information Technology degree. With us today is Josh Mikoff. He has 23 years of experience software development. He has deployed graphs at an enterprise scale at Optum. He's assisted many businesses with deploying data structures and databases. He has also volunteered at JDRF. So some housekeeping items today. We have questions and answers. If you have questions, we please would like you to submit them anytime throughout this presentation. If you just navigate to the Q&A, you can go in there and submit a question. Also, this webinar is being recorded and will be available within about 2 or 3 hours after the presentation. If you have any issues, please contact one of the panelists and we'll help you. With that, let's get started with Giraffle. Josh, if you're there, if you can go on mute.
Yep, I am here. Can you hear me?
Yep.
All right, so I'm going to go ahead and, can you go ahead and pass the screen sharing over to me so I can share my slides? All right, John, can you see it?
Yep.
All right. So John gave my introduction. He and I worked together at Optum, and we were working with Tigergraph, and we saw a need, and we decided to create a little tool here. So to start off with, Giraffle is a plugin for Gradle, and it allows you to use Gradle with Tigergraph. So to start off with, we should talk a little bit about what a build tool is real quick, and then we can explore how we can utilize some of those features of a build tool to help us with database deployments. But a build tool is really a tool that is used to automate tasks, handle your dependencies, and help you save a little bit of time by determining whether or not a piece of work needs to be done again. There's several different build tools, but Make, Maven, and Gradle are some of the more popular ones, or at least in the worlds I live in. There's others, but Make was used back when in C programming. It basically looks at your source files and compares them with the outputs timestamp of the output files, and it could basically help you skip recompiling a file if it hadn't changed. Maven came around for a lot of Java development, did a lot of the same things, but also added into that some the ability to download dependencies from other repositories. And Gradle also does all the same things that Maven does, but the language and the way of expressing how to build your application is done through a scripting language as opposed to an XML file. And then what I've found with Gradle is there's a lot of hooks available that let you expand the use of the tool to add other features, and that's what I've done with Giraffle. So if we think about what we're dealing with in a database and deploying database objects, it's a little bit different than what we do with most build tools, because we're not actually compiling any code. We have we have basically scripts that need to be executed against an environment to set up your schemas or create queries or even execute your queries. So the features of a build tool that I'm taking advantage of in the database deployment is really, it helps me automate and script out things for schema creations, installing, and actually executing queries, creating loading jobs, and also executing them. And then there are some certain features that are available inside of Gradle that let me basically abstract certain things like our environments and our credentials out of our scripts, and we can use them. We can have the build tool itself inject those things, and that way we can keep it out of the code. So I guess that brings us to what is Giraffle. Giraffle is a plugin that basically takes the GSQL shell and it injects your environment information, your username and your password information from Gradle into the GSQL client, and then it executes your GSQL scripts. It's, from that standpoint, it's actually a pretty simple tool. So one of the things that this does for us, though, is it gives us the ability to keep the code in a local environment, but execute it against a remote environment. When you first get started with Tigergraph, you probably have a Linux VM available, and you can log in and into that VM and start messing around executing the GSQL shell. But fairly quickly, you get to the point where you realize, if I want to take this to an enterprise level, I can't log into the server that Tigergraph is running on. And you very quickly get to the point where you realize, I need to be able to write my scripts on my local machine and then execute them remotely. And that's where Giraffle comes in, and it really helps you do that, because it lets you keep your code local and execute it remotely. And the other thing it also makes it easy to do is actually write or execute your code against multiple remote environments. And that becomes important when you start progressing your code through different dev, test, and stage environments. So the big question is, how do I use Giraffle? The way you use Giraffle is you take a build file for Gradle, and if you're not familiar with that, here's an example of what a build file looks like. And the important piece is we need to have a plugin, and the plugin for Giraffle is invoked by putting the ID and the version in the plugin section. Once you've done this, you now are able to use Giraffle, and Gradle will actually go down and download that from its own plugins repository, and you don't have to download or do anything other than have Gradle installed. I touched on this earlier, where we were talking about having things like your host name and your username and password abstracted from your code. In Gradle, that is done by what was called properties. And so this is how you pull in a property inside of Gradle. And with Gradle, you have a couple different ways of getting properties into your project. One is by having an actual file, a properties file. The second way is you can set some environment variables. And then the third way is by having or by adding those on the command line when you invoke Gradle. Any of those three manners, you can get your properties into your build. And by using those three methods, you can keep your passwords and environment-specific pieces of information out of your code. And then we go ahead and set up what are some Tigergraph global variables based on those properties. And then when we have any of these tasks that are going to get executed against your Tigergraph server, they use these parameters that were set up here. And so this is a super simple build file. And this is actually where I want our presentation to stop, and where I'd like to turn this into an interactive session. I have a Tigergraph cloud instance rolling right now, and I have a couple of build files that I'd like to use to basically show you how to deploy the code against, or deploy a schema against a Tigergraph cloud instance. And I'll also show you how we can use an HTTP task to actually post data against the REST endpoint to actually effectively load a Tigergraph cloud instance from a local environment. From there, we can keep on going. So John, do we have any questions, or do you have any questions you want to ask?
Yeah, one question. At what point would you advise somebody to use Giraffle, the tool Giraffle?
Yesterday. So the point at which you should start using Giraffle is probably when you start the project. By starting it, by using it at the very beginning of the project, you end up, in a lot of ways, it forces you to make your project repeatable, right? And it also really helps when you start onboarding new people who are working with you to allow them to be able to quickly pick up and effectively be able to get rolling in their own development environment, because you've already articulated everything in a repeatable fashion. So right from the beginning is a good time to start, in my book.
That's the only question.
That's the only question. Okay. So I guess
if you have questions, please just submit a question and answer, and we can bring that up. Thank you.
Yeah. So I'm gonna bring up my my Tigergraph cloud instance. I want to kind of show you how to use this in person, and I think that's always a valuable exercise. So what I want to show you is we have I got basically a blank Tigergraph cloud instance here, and I want to show you my my build file. And John, is the text here too small, or are we okay?
Maybe bump it up one notch.
Okay.
There we go.
All right, perfect. So here's a more complicated build file. Not complicated or overly complicated, but it pulls together a lot of these different concepts. And I'm going to skip down to the section where we actually create a schema, and kind of to roll through how that works. So you can create a task that will, any task basically executes a GSQL file. So if we take a peek here, I can show you my schema creation file. So here's a GSQL file that will create 2 vertices and 3 edges. And you can see from the path, schema/schema.gsql. And then you can see over here, we have schema.gsql. And basically what we're going to do is this task will execute this, this script on any server we want. So that's actually what I want to do right now. So I'll show you what we can actually do is we can ask Gradle to show us our task, all the tasks we have defined. And you can see we have a task right up here called create schema. So that's what that's going to be the task we're going to run. And so what it's doing is it's using my properties files to where I've put in my properties files, the address, the host address of the Tigergraph server, and I've put in my credentials into that properties file. And then it connects to, using the GSQL client, it connects to the Tigergraph server, executes my script, and then it exits. So having done that, we can now come over here, and if we refresh this, so there we go. After executing that script, we now have a schema. So of course, the schema is not very interesting without any data to look at. So I'm going to show you in our DB scripts. I have a load section, and I actually have 3 different load files. And so if you guys have played with load files, this is obviously a fairly simple one, but I think it gets us down the path where we need to be. So I have 3 different load files, and then if we go back to our build file, we have, let's go ahead and find it. We have tasks defined to create all of our loads. So they start right up here. So I can actually execute those tasks real quick here. And so now I'm connecting to my Tigergraph cloud instance, and I'm actually just creating those load files. Having done that, I can now take a local CSV file and post it against the REST endpoint. Just to give you a real quick peek at what that looks like, I have a data folder here, and you can see it's just a standard CSV file. So I have a task set up to run all my load jobs. It's called all load. You can see that under loading tasks. And so what this is actually doing is it's connecting to the Tigergraph REST endpoint, where I've generated a secret, and then it takes that secret and it uses that secret to generate a token, and then it puts that token into the authorization header with each of the remaining REST requests, and it's actually posting the CSV files to the REST endpoint for the server. So now that we've actually done that, if we look at, I believe it's load data, you'll see over here on the left, or on the right, that there are 793 vertices that have been loaded and 1,600, almost 1,700 edges that were loaded via the REST endpoint. And from there, we can obviously see that there's some data loaded. So there's a lot of parts and pieces there that just kind of happened. And so any questions or comments, or John, do you have any other questions that have come in?
No questions that have come in through the feed yet. If you have a question, please submit it. One thing I did want to go through was if you go back to your build file and you can see where you structure the tasks, just want to go through sort of one task. and just walk through each of the lines for the task, how you gave it a description, how you give it a group, and then how you can actually execute an actual command against the server. One of the tasks was ls. So you
There you
create,
go. That's a good one. Sure.
yeah, so you created one that was actually executing a task against.
Right. So let me, So so here the task John is talking about is called show schema. And there's two different ways of telling a GSQL task what to do. We either give it a literal string as a command to run, or we give it a more complicated file path that executes that file. And so in this case, we have a simple command of ls, which just runs the ls command. So it connects to the database and runs the ls. You know, this is another favorite. We'll do we'll create a new task and we'll call it nuke schema. There we go. We could blow away our entire database just by running the nuke schema task. Hey, John, it looks like we got like 4 more questions that came in.
Yeah, can you see them?
If you want, can you read them to me, or I can?
Yeah, yep. So one is where do you keep your token to use SSL?
Okay. So yeah, that's a good one. So when you're running against an SSL or a TLS encrypted session, like you are when you're running Tigergraph Cloud, in order to connect, you want to be able to verify that you're not there's not a man-in-the-middle attack going on. And so the way you do that is you get your cert credentials, and once you have those cert credentials, you store them in a file of basically the public key. So what I have here, well, actually, let's see. So here's an example. I connected to the Tigergraph server and I extracted the public key, stored it in a text file, and I put that in my repository. And then in order to make use of that, what you need to do is actually right here. If you take a look, you'll see that up on line 30, I have a variable, or a property, I should say, that has the path to the cert. And then down in the Tigergraph section here, so line 61, I do a quick test to see if that variable is initiated. And if it is, I use the CA cert and I set it to that path. And then every time the GSQL client connects, it verifies that you are indeed talking to the Tigergraph server you believe you are.
Can you walk through the command, how you pulled that CA cert?
I can. I'll be honest, I don't remember everything. However, I do write everything down. So this also, by the way, is the documentation site that pretty much should be able to walk you through everything you need to know in order to use it. But in order to get a CA cert, you can basically execute this command replacing the Tigergraph server with your actual Tigergraph server name. And so it just uses the SSL client to connect on the SSL port of your Tigergraph server, and then it takes the output of that and runs it through the 509 filter and outputs it as a text file. And so that's how you do it.
Let's see, we have another one on creating a new task to count vertices and edges.
How do we create a new task? Well, that's more of a GSQL question, right? I mean, basically, I kind of showed you how to create a new task, right? So if you had a script that would count your vertices and edges, you could basically put that into a GSQL file, and then following a pattern like this, put it in the file, and then you could execute that GSQL file to install that query on your server or on your Tigergraph server.
Let's see, there's what ports are being used by Tigergraph Cloud?
I think it's port 14240, which would be the standard UI.
And then
Yep.
port 9000 for the REST service. And I will mention there is the ability to call account REST service. So to get your vertices and edges, you can call one of the built-in REST endpoints to grab that data as well.
Yep. So it looks like there's a question about the GSQL highlighting. So in other words, as you guys may have noticed, I'm a fan of Vim, and so that's how I like to roll. So I actually wrote a GSQL highlighter, or I'm sorry, a Vim syntax highlighter for GSQL. So let's see if I can find that. GitHub. Oh, no, that's not it. I think it would be under, I think it's GSQL Vim. Here it is. So yeah, just a quick and dirty little syntax highlighter. So yeah, if you like Vim and you wanna have syntax highlighting, you can install that into your Vim.
There's another question that just came in. What are the steps to add a new environment? So maybe go through if you were to spin this is your first time using Giraffle and you're ready to spin up a new environment, what would the first steps look like?
Yeah. Okay. So if we take let's just take a peek here, right? Here's our project directory, and we got a build file, got a cert file. There are two property files here, right? So I'm gonna just kind of highlight those. There's my two property files, Gradle properties and Gradle-local properties. So I'm gonna go ahead and show you my Gradle properties because there's nothing private in there. And it just sets up some basics, like the name of the graph, where the REST port is, whether I want it to connect via HTTP or HTTPS. And then I've actually explicitly left the usernames and passwords blank because you shouldn't be installing, or you shouldn't be committing those to your repository. I have a Gradle-local properties file, which I actually explicitly keep out of my Git repository, and in there I actually fill out my username and my password, and I leave everything else unset. And I'm not going to show that to you because it has my private information in there, but you can basically create a Gradle-dev, Gradle-production, Gradle-stage. You can create different properties files, and you can fill out those properties, and those properties will get injected at runtime when you invoke those environments. And that I guess environment ability is actually that comes from the what is it? Net Salmon Properties plugin. So basically, if I wanted, if I wanted to, let's see, Gradle-dev.properties. I could basically create a new file, and I would say, you know, TG or Tiger Dev, and then I would actually get rid of the rest of it because I'm only overriding the properties that I don't want to use or that I want to change. So by creating that new dev properties file, I've effectively enabled my script to be able to handle different environments. And now if I want to execute this against my dev environment, I just on the command line specify a property called environment name. And, you know, create schema. And now it would connect to that server instead. Of course, that server doesn't exist, so I'm not going to execute it because it would fail. But that is how you enable different property or different environments. And notice I didn't have to change anything in my code. I just had to add a new property file for that environment. It looks like there's a question about how do you keep a file from being added in Git? That's a good question. So there's a hidden file in, or there should be a hidden file. Let's see. Actually, there's not in this one. Actually, maybe there is. There it is. It's the git ignore file. So if you take a look at the contents of my git ignore file, there's several things I put in there. Namely, you know, I don't want DS store files. If you're using ID, nobody else needs to see that. If you're using Gradle, the output doesn't need to be stored. And of course, the metadata from Gradle doesn't need to be stored. But in particular for this project, the Gradle-local.properties file, that's what prevents you from accidentally committing your user credentials into the repository. Let's see. We also have a question about executing tests after you load. Yeah, you can. You know, I think the earlier question about how do we count vertices and edges. If we know how many vertices and edges we should be loading in our load file, we could actually build up a test case that would execute that query, get the results back, and we could actually break the build if the numbers weren't the same. It actually might be, I think it might be valuable right now to kind of go over here and go over how we actually enable the ability to execute against the REST endpoint. So the Gradle ecosystem is fairly, I would say, active, and there's a lot of plugins to do a lot of different types of things. In this case, what you can see is I created one plugin, which is pulled in on line 12, and then I'm using two others. One of them is the Net Salmon Properties, which is what allows us the ability to support multiple environments. And then the third one you see there is actually an HTTP plugin. And what that does is it actually adds support in Gradle to make any type of HTTP call. And effectively, when we're hitting the REST endpoint, that's what we're doing. So you're actually able to use a lot of other people's code in these plugins to make your life easier. So if we jump down to the config section here of the HTTP, what we're actually doing is we're setting the REST endpoint addressed as our base URI. And then you may remember me mentioning it before, but there's a task that is created that actually takes a secret, a GSQL Tigergraph secret, posts it against the REST endpoint, and then that endpoint gives you a token. And then if you set that token in your authorization header, it handles all of your authentication for you. And so that's what we're doing here. We're saying, hey, I'm going to use that token in order to authenticate myself, and here's where we're going to execute all of the HTTP requests. So if we go down to HTTP task, you'll see, here are the basics of posting, making a post. You set the rest of the URI path, so it adds it onto the config that we set earlier, and then we set the query parameters. Tag is how we tell Tigergraph which load rule to use. This is how we're mapping the file we're posting into the parameter inside of the load rule. And then we're providing some metadata about what we're doing. So the separator is a comma, and the underlying character is a new line. And once we've done that, we can basically we can create a file stream and set that as the body of our HTTP request. And that's how we load it. Let's see, anything else?
One question on how would we test the GSQL scripts using a REST call?
How would we test the GSQL? Well, I need a little bit more information to answer that. What do we mean by test it? Are we to test to see whether or not your GSQL worked, like syntactically, or are we testing a load? I guess I'm not quite sure what we mean.
Yeah, how would they execute this load or this HTTP request against the REST endpoint to test to make sure it's actually running? Is it do they run a task and it just magically works?
Well, if you have to create a task, right? So, any of these REST endpoint, like I gave an example here of a post. When you install a graph, when you install a graph, I think you end up, or I'm sorry, when you install a query in Tigergraph, it creates an endpoint that I think is, I don't off the top of my head remember what it looks like, but there's a new REST endpoint available that if you do a GET request on that REST endpoint, it'll pull back the results in a JSON format.
Perfect. Yeah. Can you access the endpoint in the GUI interface?
Maybe.
So you can go into your Graph Studio, and one of the do you have any queries in here?
Here, I do. I just waiting.
So while this
yeah.
loads, you could create a task that gets REST endpoints, and it will give you all your REST endpoints. That is one of the available endpoints that you can hit. Another thing is, once this query gets installed, if you go to the Graph Studio, you can actually see the endpoint as well.
Okay, so let's see. we do Gradle, create query, get financiers, and create query, get organizations. All right. So that should actually create those two queries.
So you have the query stored locally, and now you're pushing
Right.
it,
So
creating it?
yeah, let me. So that's it's actually. So yeah, if we go to query, here's get financiers, and here's get relationships. So there are the two queries in question, and those are actually being installed right now.
So I just want to, I
Go
think
ahead,
it's
John.
important to emphasize that what you're doing is you're developing outside of Graph Studio. You're writing all of your code and logic in GSQL, and then organizing that, and then creating tasks, and then also allowing the ability to do task sequences to build this environment. Is that correct?
Yeah, it is, and you know that's. I think that's important, right? Because it's useful and handy to be able to use the Graph Studio in order to you know, maybe explore some of your ideas and how to write queries. But when it comes time to move those queries from one environment to another environment, or to share those queries with other developers who may not, or who potentially, or maybe even should have their own, you know, instance of Tigergraph in those early phases of development, taking this data out of Graph Studio gets to become a little bit cumbersome. And so being able to have it in a textual format that you can store it in a Git repository and actually share it like any other piece of development, I think becomes very important. And yeah, like to your point, John, you can see I have a very particular way that I like to organize my my code. I have a DB scripts folder, and I have usually a subdirectory for loads, a subdirectory for queries, and a subdirectory for schemas. And you know, again, then all my actual tasks refer to these individual files. Now, one of the things we might actually find interesting here.
Before you go into the next one, can you go back to the Graph Studio and just show where the icon is? If you click on your query, and then you see that globe next to the trash sign.
Oh, look at that.
So if you actually want to see through the GUI where your REST service is, just click on the globe, and you'll actually get the REST endpoint that was created.
Yeah. So maybe if we want to put Josh on the spot, we can maybe try to create a quick task here that will execute that query. Let's call this what is it? Yeah, let's call it get. So one of the things I want to, I guess, call out is this actual graph came about from a discussion on Tigergraph's Discord server. There was a particular individual there who was trying to figure out how to use Giraffle, and I was able to work with him by having him, you know, basically create a couple of bare bone pieces of information for me and create a Git repository with that. And then I was able to clone his Git repository, and I was able to run through creating a build file and creating the load rules and all of these different steps. And I gave him a pull request, and he was able to get that code, and then he was able to run he'd run the build file against his instance. And so it really highlights the collaborative nature of this tool. It really enables that kind of collaboration. So let's see here.
And just
so what we're doing,
yeah,
go ahead, John.
I was just going to say, just to reiterate what you're actually working on or doing.
Yeah, so here's what I'm doing here is instead of doing a post, we're going to do a get, because if you look, the query endpoint tells us we need to do a get. And then we're going to set the path to be query. And then I'm using a property for the graph name, so we'll leave that there. And then we need the actual query name. And then, now here's where things might get a little bit tricky. Well, not super tricky, but.
Are you missing a slash in front of get financiers?
I am, John. This is how John and I work together. I type and he tells me where my typos are.
Yeah.
Now here, what we would really do in real life is we would maybe try to do this a little bit differently, maybe by setting up a property, but I'm just going to go ahead and hard code it, because we don't have time to think about it. So what I'm just doing real quick here is I'm looking up, I want to get a look at one of the organization commodity contracts. There we go. All right. Now, the problem is I don't necessarily remember how to print this off. Here we go. That's all right, I don't have to remember. All right, let's see if this works. If it doesn't work, we will try again later. We're actually kind of running up on time, but let's see if we're able to pull this off. All right, failed to convert user for text ID for parameter org. All right, well, so this is a success and a failure at the same time. So let me explain. If you look, what's actually going on here is we actually got and printed out a JSON response from the REST endpoint. It looks like I didn't actually give a proper value as an argument, but we did actually successfully execute a query against the REST endpoint. I do want to be, I think, mindful of the time. John, I guess I can turn it back over to you. We can take care of any closing items you need to take care of.
Sounds good. All right, thanks. Can you just on share?
There you go.
So if you have any questions about Giraffle or how to use Giraffle, we included a community chat link. So if you go on this link, there will be a chat room, I think about 100 Tigergraph developers right now. And if you have any questions or basic questions of how to get started or how to get Giraffle installed, or how to set up your first Giraffle project, or how to integrate Giraffle on the cloud, or any other questions, you can go into the community chat and ask fellow developers. Also, we have a community forum. It's at community.tigergraph.com. And then if you want to talk to Tigergraph developers, we do have weekly office hours. We've also included a couple of additional resources if you wanted to get started with Tigergraph Cloud, one of the cloud products that you saw today. It's free to get started. You can spin it up and play around. Also, we have a Graph Gurus event coming up, Graph Gurus 31. It's about thinking in GSQL. So how do you actually do all of the things that you saw today? How do you think through load scripts? How do you think through how you should take a CSV file, and how you should think about how that's going to get constructed into the graph? How do you think about how you should write your queries? How do you think about how to interact or write parameters or do accumulators? Just thinking in GSQL, this is going to be a 1 to 3 part series, or maybe a 5-part series, depending on sort of the interest in this space. That will occur next week, Wednesday, March 18th. Of course, that's going to be at 11 a.m. Pacific time. And that is it. So thank you for joining, and we'll see you next time.